Hello everyone. Now let us solve problems on the KCL and KVL. First question is find current I in the following circuit. This is the given circuit. Now voltage across 1 ohm is 1 volt. Why? Because in parallel circuit voltage across all the elements is same. Voltage across 1 ohm resistor is 1 volt. Similarly voltage across current source is also 1 volt. Okay, now find the current through the 1 ohm resistor. So what is I? I is equal to V by R by Ohm's law. So here it is 1 by 1 is equal to 1 ampere. Direction is for passive elements current always enter at positive terminal. So this is 1 ampere. Okay, now let us this point or node is A. Apply KCL at node A. So what are the entering currents? This current is entering to the node and this 1 ampere is entering to the node and it is leaving the node. So this is I plus, so this is 1 is equal to 1. So what you are getting? I is equal to 0 amps. Next question. Determine the voltage across the inductor in the given circuit. Okay, this is the given circuit. So voltage across inductor is given as VL is equal to L dIL by dt. Now what is the IL? So this is the passive element. So current is enter at positive terminal. So this is IL. Now this is let this node is A. So here the current, this is the current source. So current is coming towards this node. Okay, what is this current? E power AT. And this source, this is also current source. The current e power bt is coming towards this node. So by applying KCL at A, what is IL? Sum of leaving currents is equal to sum of entering currents. So e power AT plus e power bt. From this expression, VL is equal to 1 into d by dt of e power AT plus e power bt. If you derive this, you will get VL is equal to A into e power AT plus B into e power BT volts. Next question. Find the V1 across the 2 ohm resistor for the network shown in the below figure. This is the given circuit. Okay, in the circuit they give one hint. What is the hint? The voltage across this 1 ohm resistor is 1 volt. So current flowing through this resistor is, what is a resistor? What is the current? By Ohm's law, I is equal to V by R. So voltage is given as 1 volt and the resistance is 1 ohm. So this is 1 ampere. Now the direction of current is, for passive elements, current is enter at positive terminal. Okay, so this is the current. So this value is 1 amps. In series circuit, current is same. For all elements, current is same. So the 1 ampere is flowing through this R and this R. That means same current is flowing 1 amps. From here, it is came 4 amps. Okay, so apply here KCL. Let it be node A. So apply KCL at node A. So let it be current I2. So what are the entering currents? Only one entering current. So 4 is equal to, what are the leaving currents? I2 plus 1. So what you are getting? I2 is equal to 4 minus 1, 3 amps. Now what is the voltage? By Ohm's law, voltage V is equal to IR 3 into 2, 6 volts. But see, the current is entering at negative terminal, that is negative polarity of the passive element. Current should enter at positive terminal of the passive elements. So the current is minus. So this is minus 3. You will get minus 6 volts. Careful with signs. Okay, positive and negative. Next question. For the segmentation of circuit shown in the figure, IR of t is equal to 4 e power minus 6t plus 8 e power minus 5t amperes, and IL of 0 is equal to 6 amps. Then theta is equal to how much? This is the given circuit. Let it be node A. Apply KCL at node A. What we get? So entering currents are, this is IL of t, this is one entering current, and source current 12 cos omega t minus theta is another current. So IL of t plus 12 into cos omega t minus theta is equal to IR of t. Now substitute t is equal to 0. So you will get IL of 0 plus 12 into cos, this is minus theta. So omega into 0, 0, 0 minus theta is equal to IR of 0. IR of t is given as 4 e power minus 6t plus 8 e power minus 5t amperes. So what is IR of 0? IR of 0 is equal to 4 into e power minus 0 plus 8 into e power minus 0. So e power 0 is 1. So you will get 12. From this expression, IL of 0 is 6 plus 12 into cos of minus theta is cos theta. IR of 0 means 12. So from this, what is cos theta? Cos theta is equal to 1 by 2. Theta is equal to 60 degrees. Next question. Find the E for the following network shown in the below figure. Okay, this is the important question. Okay, this is the given circuit. If we observe here, this is 0 volts. 0 volts means this is ground. Okay, if you observe here, this is 10 volts. If they given voltage at any node like this, it is this node to ground. This voltage is represented as this node to ground. That means from here to here, this is 10 volts. Okay, so this is ground. This is ground. You can connect like this. So you can draw the circuit. Okay, the circuit become like this. Okay, so I draw the half of the circuit. So from here to here. So this is the closed loop. Now, so current is flowing like this. Okay, so if current is leaving the positive terminal of the source, it is negative. So if you apply KVL, what we get? So here it is leaving, so it is minus 2. So here also it is leaving, minus E. Here current is leaving, so minus 8. Here current is leaving, minus 10 is equal to 0. From this, E is equal to minus 20 volts. Okay, or you can write here, this positive is connected to negative terminal of the battery, and this negative is connected to positive terminal of this battery, and this negative is connected to positive terminal of this battery. So you can add all these things. So what we get? 2 plus E plus 8 plus 10 is equal to 0. This is also correct expression. Minus 20 volts. You can follow anything, but you should get same answer in both the cases. Next question. Find the Vx for the following network. This is the given circuit. For suppose current I is coming from here. Okay, so current I is coming from here. Whenever reach to this node, current is going in this way and in this way. If you observe here, this is open circuit. If circuit is open, what is the current? Current is 0. Okay, let it be I1. I1 is equal to 0. So here this is I1 equal to 0. So total current is flowing from here to here, because here current is 0, so total current is flowing from here to here. So what is the total current now? This resistance and this resistance are connected in series, so you can get I is equal to 40 by 5 plus 15, you will get 2 amps. 40 by 20, you will get 2 amps. Okay, so here this is I is equal to 2 amps. Here current is 0. So what is the voltage drop across 7 ohms? Let it be V1. V1 is equal to 7 into I1. So 7 into 0. You will get 0 volts. Now here same current is flowing. So this is 2 amps. So what is the voltage across this this 15 ohms? Let it be V2. V2 is equal to 15 I, that is equal to 15 into 2, you will get 30 volts. Now apply KVL to this loop. Okay, apply KVL to this loop, you will get, so this is Vx, this minus is connected to, sorry, this positive is connected to minus of this source, and this positive is connected to minus of this voltage drop. So you will get Vx plus 5 plus V1. Here positive is connected to positive, so minus V2 is equal to 0. Vx plus 5. So what is the V1? V1 you get 0 minus 30 is equal to 0. So what is the Vx? Vx is equal to 25 volts. Or you can apply KVL to this loop. You can apply KVL to this loop. Current is flowing from in this way, in this direction. So what is the voltage drop across 5 ohms? 5 ohms voltage drop is like this. So current is entering here, so it is positive. Current is leaving here, so it is negative. Let it be V3. So what is the V3 now? V3 is equal to 5I. 5 into 2, you will get 10 volts. So apply KVL to this loop. So this plus is connected to minus. Again this plus is connected to this minus, drop of the 7 ohms resistor. Again this plus is connected to this minus. So you can get Vx plus 5 plus V1 plus V3. But here this positive is connected to this positive. This is positive, this is positive. So it is minus 40 is equal to 0. Vx plus 5, V1 is 0 volts plus V3 is 10, minus 40 is equal to 0. So if you solve this equation, you will get 25 volts. Next question is find the Vx. Okay, this is the given circuit. If you observe here, 8 amperes is coming from this branch. So this is 8 amps. So 4 amperes is going like this way. So here, let it be node A. If you apply KCL here, let it be current I1. So what are the currents? 8 is equal to, entering current is 8. Leaving currents are I1 plus 4. So if you solve this, 8 minus 4 is 4 amps. I1 is 4 amps. Okay, so here this current is coming like this way. Current is entered here. If current is entered here, this is positive, this is negative. Here current is entering here, so this is positive, this is negative. Let it be V1, let it be V2. So what is the V1 here? V1 is equal to 4 I1, 4 into 4, 16 volts. What is V2? V2 is 3 into 4. Okay, this is current is 4 amps. So V equal to IR, 3 into 4, 12 volts. Now apply KVL to this loop. Okay, this positive is connected to this negative. So V2 plus Vx. Next, this positive is connected to this positive. If positive are connecting, you will get minus. Minus V1 is equal to 0. So what is V2? 12 plus Vx, what is V1? 16 is equal to 0. So from this, what is Vx? 4 volts. Thank you for watching.